In the previous video, I showed a motivating example for using arrays where we were taking a look at how we could use them to define a collection of servo angle positions and iterate through them. So in this video, I'm going to talk a little bit more about arrays and introduce a lot of the terminology surrounding it. So first, an array is basically just a collection of different values, right? So we could use them to, collect an assortment of color values, a group of servo angles like we just saw, a list of musical notes. And basically what it prevents us from doing is having to do something like this, where we're defining a bunch of different individual variables, because this doesn't give us a great way to be able to loop through them or organize them and refer to them as a collection. What arrays do is allow us to group these values together to do like a similar operation, or to sort through all of them and find what we're looking for. So instead of doing something like this, what we do is we define it like this, where we say we have one variable, but inside of that one variable there are 5 different values, and we can access those 5 different values using the square bracket notation. So exactly what I said. It's a data structure, or a way of collecting data together, right? So it's a little bit above just the primitive data types of just an integer or a float. It's a collection of these different values. So an array can be any type, but when it is defined as an integer, all of the values inside of it have to be an integer, or if it's defined as a float, all of the values inside of it have to be a float. And then an array has a name, so we give it a variable name just like we do any other type of variable. And then it also has a specific size that can't change. It can't change throughout the life cycle of the program, but we can upload a new program where it has a different size, right? But here, this has 5 values, and it can only ever have 5 values. We are actually able to read these values or write these values. We can modify them, but we can't change how many values are inside of there. And so we introduced this term called indexes last time, which is kind of the position of the values inside of the array. So we start counting and programming at 0. So the first value is located at index 0, the second value is located at index 1, and so on. And we can access those values using the square bracket notation. So if I just say value 0, that will retrieve that value there. But if I say value 0 equals, 12, what it will do is it will actually assign that position inside of the array to have that new value 12. All right, so here is how we declare an array. We've seen this example before, but we first put the type, then we put the variable name, and then inside of the square brackets we can say how many elements there are. This is if we want to define an array without some initial values inside of it. We just need to define the size of it, because that tells the Arduino how much space in memory to allocate to it. So we have to declare the size. We can't just leave that blank. And then if we need to refer to one specific value within an array, if we need to reference it, what we do is we say the variable name, and then inside of here we place the index, where the indexes will start again at position 0 and go all the way up to the total number of elements in the array minus 1. So for some integer array called val, where we define it as size 8, the first index is 0 and the last one would be 7. And this is how you could declare and initialize it. So we would still have here on the left-hand side the type, followed by the variable name and then square brackets, but we don't need to put the size inside of here, because what it's going to do is infer the size from the number of elements that we're assigning here on the right-hand side. So these are going to be the initial values that we're setting it to. So we put these inside of curly brackets and we separate them with commas, and it's going to infer that the size of this is 3 because there are 3 initial elements inside of there. So if we want to do some array declaration and then do an assignment, what we can do is just say the type, the variable name, and then its size, and then we can make the assignments after the fact. So I could say variable at some index defined by this value equals value, and then variable at this other index 2 equals value 2. So this is updating the values or assigning the values at this specific index, and that is a valid operation. So we can both get the values and set new values inside of the array. And then to get the length of an array, we use the size of. And so we went through this in the previous video. But what happens is size of tells us how much space and memory is allocated to that array. So first we determine the total size of how much is allocated to that variable that we use to represent the array, but then we need to divide that by the size of one of the specific elements, because an element in an array could be comprised of multiple blocks of memory. So this is going to give us the length or the total number of elements in the array dynamically, which is helpful for iterating over them. We need to make sure that we keep our indexes bounded and valid so that we don't try to access a index that doesn't exist within an array. So to continue on and kind of see some more concrete examples, this shows an example of defining some integer array that is size 5. The name of it is servo position. This is another example of declaring it, but actually initializing 5 different values. So if we did this here, these would all be set to some like initial value. But here what we're doing is we're specifically saying 45, 90, 0, 180, 135. So here you can sometimes assume that it's 0, but sometimes there could be some data still left in memory. So you don't want to assume any specific values if you're just declaring a size. You'll then want to come back later on and set specific values inside of the array. And then again, accessing the array, we can access all valid indexes here. So our valid indexes for something that is size 5 would be 0 through 4. If we tried to access position 5, that would be an illegal access. It would not be defined. All right, so this is our for loop example, right? So an array is a finite number of values, which is a great candidate for a for loop if we need to loop over each individual value in an array. So this kind of shows this process of doing it. So we could declare some array up above, and then I will represent our index. Our I control variable will represent the index of our array here to access each one of those different values here. So you could either just say, well, I is less than 5, since there are 5 values here, you could count it up. Or if you might change your code to include more values and you don't want to have to update that value of 5, what you can do is have the Arduino dynamically compute it to say size of val divided by the size of val 0, meaning take the total size of the array and divide it by the size of just one element of the array to give us the total number of elements. And we add 1 to I each time so that it advances through our different valid indexes. And here what it would just do is print out those different values. And kind of to close out here, this is our example that we went through in the previous video, where we were using the angles in an array to write them to a servo. It's a very similar process to what we just looked at. But yeah, these are some great candidates for how you can incorporate an array into your Arduino projects.